Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get ready.
GDI engine, perhaps one of the most discussed topics on automotive forums. The peak of discussions coincided with the early 2000s, when Japanese cars with an unfamiliar index in the model name appeared on the Russian secondary market. Happy buyers were faced with previously unknown problems of the power system. The situation was complicated by the fact that service workers were not ready, not only to repair such an engine, but even to find the cause of the malfunction. To be fair, it should be noted that in recent years the situation has improved somewhat. Almost diesel. What does the abbreviation GDI, which can be seen on the engine and body of a Japanese-made car, stand for? It stands for gasoline direct injection, translated as gasoline direct injection. The English phonetics of this abbreviation is GDI. In Russia it is pronounced as GDI, sometimes ZHDI. Motorists nicknamed these engines Jedi. The letters GDI first appeared on Mitsubishi Galant Lignum cars in 1996. Other Japanese automakers have their own designations of direct injection. Toyota has D4, Nissan has DI and Neo DI. The picture is the same in Europe. Volkswagen Group designates such engines as FSI, Daimler Chrysler, CGI, Renault, IDE, Ford, SCI. So, GDI is a new type of gasoline injector engine with direct or direct injection, DI, which is the same thing. Their injectors go directly into the combustion chamber, rather than into the intake manifold as with distributed injection. In this way, the gasoline unit resembles a diesel. The basic idea is to force the engine to run at least part of the time on an ultra-poor fuel-air mixture in order to save fuel and reduce emissions. Differences in design. In order to create the conditions for such a working process, gasoline must be fed into the cylinder, which is under compression stroke pressure. Since the traditional pump located in the gas tank is unable to overcome this resistance, an additional device is required, a high-pressure fuel pump, HPF. HHF engines have an unusual piston head shape due to the need to impart a strictly calculated vortex-like motion to the fuel supply. Due to the fact that the engine with NV, as well as any other internal combustion engine, cannot constantly operate with insufficient mixture concentration, these motors are characterized by a more complex program of operation, providing a combination of economy and power modes of mixture formation. Finally, GDI engines have two catalysts, iridium and platinum. The first one is designed for accumulation and burning out of nitrogen oxides formed at work on superpoor fuel-air mixture, the second one, for normal mixture formation. By increasing the compression ratio to 12:13, the powertrain's liter capacity increased while reducing fuel consumption and exhaust toxicity. On a meager ration. Before considering the operating modes of the GDI engine, it is necessary to recall a little bit of theory. A mixture of gasoline and air in the cylinder can ignite only when it has a certain concentration. The optimal value is 1 part of fuel per 14.7 parts of air, stoichiometric composition. The maximum amount of air per 1 volume part of gasoline in an injector engine should not exceed 24 parts. The described engines can run on an ultra-poor mixture, up to 140. How can this be explained? Fuel in the cylinder after injection is distributed unevenly in the volume due to its reflection from the notch in the bottom of the piston, which at the moment of injection is in the uppermost position, end of the compression stroke. The fuel plume has a compact shape and, when reflected, forms a reverse vortex. With a generally poor mixture, near the spark plug it is close to stoichiometric composition and is successfully ignited. The flame then ignites the adjacent layer, the combustion intensity increases, and the process covers the entire cylinder volume. The described mode, ultra-lean combustion mode, is also called layer-by-layer mixing or combustion and is maintained by the ECU program. During quiet driving at speeds of up to 100, 120 km per hour. 2 meals per day. Unfortunately, power is not enough for further acceleration and the mixture has to be enriched to the usual level, 112 to 115. The mixture in this case is homogeneous, and is formed as a result of fuel injection at the intake stroke, when the piston goes down and the fuel plume in the form of a wide cone fills the entire opening volume. There is no reflection of the plume from the piston and the mixture is ignited after the compression stroke is reversed. This mode, superior output mode, is also activated when driving under load, i.e., when an increase in power output is required. In engines for the European market, there is a third mode, two-stage mixing. In this mode, injection is performed twice, at the intake stroke and at the end of the compression stroke. The idea is that a small portion of gasoline injected at the first stage cools the cylinder walls and helps to increase the mass amount of intake air, which allows to proportionally increase the fuel supply at the second stage of injection, at the end of the compression stroke. Tip: given the fastidiousness of the system to air quality, you should pay special attention to the prevention of the air filter. And it is recommended to clean the intake manifold every 30,000 kilometers. Who spoils the air? At idle speed, idle, the GDI engine also operates in two modes. The main one is compression on lean mixture, 625, 650 rpm. However, constant operation on it leads to accumulation of highly toxic nitrogen oxide, NO, in the catalyst, which is noticeable by an unpleasant odor from the exhaust pipe. To burn out this compound, the stick FB, scavenging, mode is activated periodically. The RPM increases to about 750, on some models to 900. By this behavior of the engine running at idle, and you can recognize a GDI engine. On a serviceable engine, purge is briefly activated after about 4 minutes. The stick FB mode functions in its turn according to two variants: regulation of mixture formation taking into account the oxygen sensor correction, closed loop, and unregulated process, open loop. Is it worth it? What are the benefits of the new NV engine, including GDI systems, daily operation of the car in urban conditions, when the power unit is constantly operating at stable idling speeds, is accompanied by noticeable fuel savings, about 20 to 25%. In urban areas, fuel consumption remains the same as for a unit with distributed injection. The peculiarities of the principle of mixture formation provide that GDI, with an explosive character, thrust, and power of the unit, exceed similar indicators of a conventional, distributed, injector. It is cleaner from the ecological point of view. However, the Russian owner has nothing from it, unlike the Japanese. After all, islanders buy the same Mitsubishi with GDI engine mainly to get a favorable discount on transportation tax, and they shift the repair of the power unit to the future buyer, as a rule, a foreign one. Some people claim that GDI engine starts better in wintertime. It should be noted that of the direct injection engines of Japanese and Korean production, the most reliable and refined motors are on Mitsubishi cars. Japanese adventures in Russia. And yet, to paraphrase a well-known proverb, what is good for the Japanese is good for the Russian is death. In Russia, all advantages of NV are crossed out by low quality of domestic gasoline. In what way is this expressed? Insufficiently clean fuel, and even high percentage of sulfur in gasoline leads to accelerated wear of the fuel injector and clogging of injectors. Repair of the latter, by the way, is impossible. If flushing does not work, you have to replace them with new ones, which is quite expensive. Most often on forums complain about floating idle speed. One of the causes, if not the main one, of such a phenomenon is the above-mentioned pump. As mentioned above, the idle speed changes in a regulated manner, in accordance with the ECU firmware. When the wear of the pumping plungers reaches a certain value, after switching to compression on lean mode, the injection pressure drops below the allowable pressure, and the computer returns the system to the enrichment mode. After pressure normalization, the processor again tries to switch the injection operation to the lean mode. That is, the frequency of switching increases, and if other factors are superimposed on the process, the periodicity becomes chaotic, which leads to unpleasant twitching on the most likely diagnosis and repair of the fuel injector, cleaning of injectors, as well as removal of soot from the intake system will be required. The fact that part of the exhaust gases is directed to the intake manifold for environmental reasons leads to sooting of the ducts, control flaps, and valves. In distributed injection systems, the intake valves are washed with fuel, which is fed by injectors into the manifold, and the problem of soot deposition is not so acute. Another problem is the lack of a sufficient number of qualified personnel to service such systems. It is problematic to determine the cause of a malfunction and make the necessary repairs even in large cities, let alone in the Russian countryside. The greatest danger for the engine with direct injection comes from gasoline. Fuels should be filled at proven gas stations. It is categorically impossible to use various additives, octane-increasing additives. This is a direct way to kill the fuel pump. Despite the serious disadvantages, the direct injection system has not yet been buried. Many owners of Japanese cars claim that they are satisfied with this engine. And the circle of automakers is expanding. For example, GDI engines are completed with Korean Hyundai Avante and Hyundai Gamma. Perhaps, in the near future, the new engines will get rid of their diseases, and the ugly duckling will finally turn into a beautiful swan. In conclusion, the gasoline direct injection engine represents a significant leap forward in automotive technology, combining efficiency, power, and reduced emissions. As we move towards a more sustainable future, GDI engines are poised to play a crucial role in meeting the demands of both consumers and environmental standards. With ongoing advancements and innovations, this technology not only enhances performance but also aligns with the global push for cleaner energy solutions. Embracing GDI technology could very well be a pivotal step in shaping the future of transportation. Thank you for watching, and stay tuned for more insights into the technologies that are driving us forward.